with you just so that I have one presentation regarding this routing. Yeah, so we were talking about why we need a routing. Okay, the very first reason is the path selection. Why? Because we have multiple route to reach to any destination. Let's suppose this is our data center. Okay, so to reach to the data center, you can see that there are a lot of pathway. Okay, so which pathway is correct to reach to this destination? We have two options. Okay, one we were saying that we have a static selection, a static way or a manual way to reach to that destination. And other one is we gonna follow some protocol, and that protocol will have the ultimate algorithm with them. With the help of with those algorithm, they gonna decide a best path to reach to that destination. Okay, and even a smaller company, even a small scale size company, mid-sized company, or even a ISP, all are using some sorts of routing protocol. Okay, ISP side, mostly you're gonna face the BGP, the border gateway protocol, and in mid-sized company, even a large-sized company, inside their network, they are using mostly OSPF and EIGRP. Okay, OSPF is basically the open standard, and EIGRP is Cisco proprietary protocol, but later on they have made it public for everyone. So now EIGRP can be used by on other platform also. Previously, it was only for meant for Cisco devices only. Okay. So routing protocol, the dynamic path discovery, the routing protocol, we are talking about the routing protocol. Okay. So how it gonna discover? It gonna discover the route dynamically, automatically. Okay. And how they gonna discover it? For an example, let's suppose if we want to go from here to point A to point B. Okay. So in that point A to point B, there may be the several steps are there. Okay. So how we gonna reach there? Maybe we don't know the destination. So we're gonna ask someone, okay, can you tell me where this shop is located? Can you tell me where this particular school is located? Can you tell me where this particular location is located? So you're gonna ask with all those guys, okay, with the each and every stop, and they're gonna give you the direction. Okay, take this route, take this route, take this route. They're gonna tell you, okay, this route is busy, this route is not like a. So this is how the protocol also talking with the different routers. Whatever the routers in between from source to destination, there are a lot of routers are there, right? So this is how they works. This is how they talks. So when we are saying there are two kinds of a protocol, okay, one is distance vector protocol, another one is link state protocol. So when we are saying distance vector protocol, in that one, basically, let me give you, I think I must have this one. So distance vector protocol, okay, simplicity with that, there are limitation with this one, okay. So let me go what I wanted to show you guys. Hmm, I think a difference. Yes, this is the difference I wanted to show you guys. So distance vector protocol is a neighbor-based network view. What do you mean by neighbor-based network view? He gonna only talk with the directly connected router with that particular itself. Let's suppose I am the router, okay, and I have two hand, and with this my two hand, there other routers are connected with my this two. So I gonna only talk with these two routers, okay. That is what the distance vector approach is there, okay. Then there will be a periodic updates of broadcast. What do you mean by periodic updates? That I gonna say to my neighbor every 30 seconds, oh, I have certain changes happen or occurred in my network, and every 30 seconds, okay, even there is no changes, even there is a even if it is a changes occurs there or not, I gonna update my whatever the routing table, whatever the information, the routing database I have, I gonna share with my nearby router, okay. But that is again not a very good scenario. Why it is not a good scenario? Just try to imagine, okay. Now, let's suppose you have a two option. One is maybe xyz.com and another is abc.com, and both are serving you the same thing. Okay, maybe both are the same social media platform. Okay, one side, when you are trying to access that one, it download to your or it appear in your browser very quick. Another one is not appearing it, so definitely you're gonna be frustrated with the site which is not downloading properly. So what you're gonna do, you're gonna definitely leave that particular platform for the better option. Okay, but why it is happening? Because of few millisecond delay, few seconds of delay. Now people don't have the patience. Okay, people don't wait for that's a very normal human tendency, that people are not ready to wait. Okay, so when we are saying the periodic update, what it gonna create a problem? Let's suppose I didn't have any changes, so periodic updates are definitely I gonna send some data from point. Let's suppose this is a router. Just imagine this is a router. Okay, and this one is directly connected. Okay, even if something not happened to this one, it gonna send every 30 seconds some packet, some data it gonna send over the network. So when it gonna send some data, of course it's a overhead over the your network. So that's not again a good scenario. Okay, why I'm trying to give you a difference why in industry we are not using mostly this distance vector protocol, the reason behind that one. Okay, all the way for examination point of view, definitely you have to read that one. From university examination, definitely you have to read that one. Okay, but from implementation point of view, in my life, I never see any company who is configuring this RIP protocol. That is basically the distance vector protocol. There are few protocols. In that one, there is one something called RIP protocol. But I gonna show you the scenario how we gonna configure that one. That's not a problem. Okay, then it's a simpler implementation. Of course, it's very simple to implement. Okay, slower convergence time is what? Means let's suppose if a certain changes happen with any of the so-called networks routers, so the information about this router, if something happen, when it will reach here, it will take time because they are periodic update, and it gonna give information to its directly connected router, and then this particular router gonna give it to his directly connected, and then this particular router gonna give it to his directly connected router. Okay, then there is something called a routing loops. Maybe if we will have time, we're gonna have a demonstration how we're gonna create a routing loops. So normally we can create it in by the help of this static route very easily. Okay, so there is an scenario where the routing loops can appear in that one. But at the same time, we have the very good approach, we have a very good algorithm which is working behind the link state, and the benefit of that one is instead of having a view of the directly connected router with us, we will have the view of entire network, entire topology. Imagine it's like a Google map. It's not like a guy you are asking, okay, what is the map of the Kathmandu? What is the map of a certain particular cities of Nepal or India or Pakistan, Bangladesh, anywhere? Okay. Instead, you have a map of overall network, complete network map. That will be definitely a very good thing for any router to reach to some certain destination, because they will have the overview. Okay, these are the certain path with us, and these are the cost attached to that path. Cost means like whether this path is easy to reach to that destination, yes or no. There are a lot of factors behind that one. What are all that factors will be? Maybe the kind of a bandwidth has been assigned between that 2 point. Maybe the kind of a computing power those routers is having. What do you mean by computing power? There are routers who are maybe 20 years back also there was a router, right? So let's suppose someone is having a 20 years back router. So definitely they didn't have a gigabit Ethernet port. Okay. So if they didn't have a gigabit Ethernet port, they can't send a data at a very higher speed or a very higher bandwidth. Okay. Those are the cost attached to that one. Okay. So if we have a multiple path, it will be very easier for a router to imagine which route is easy to go. Okay, then Another the very good important thing about the link state is it is giving you a event trigger updates. Very important thing. Okay, from interview perspective, from or even the examination perspective, they're gonna trick you here only. Okay, so one is having a periodic update and another one is having an event trigger. What do you mean by event trigger? Let's suppose again go back to this scenario. Okay, let's suppose this is our one router here, and the one router is here, and another one router is here. Okay, so in previous distance vector, no matter what happened to these two routers, whether there is a changes in their network, yes or no, every 30 second, every periodic, the time period gonna come, it gonna broadcast those kind not in broadcast these two guys gonna talk with each other. They're gonna share their database. Okay, even though there have been no changes here, and if even if there is a changes, they will send this data. Why someone is messing? Wait, one of our listeners is asking questions. Yeah, Pooja, if you have a question, you can ask, but try to ask a little bit once we finish the theory part. No, I will give you guys a time to ask. Okay, that time you can ask. Just you write down all your question, whatever comes to your mind, and once I gonna give you guys a time to ask question. That time you can ask. Okay.
Okay, sir.
Yeah. So what I was telling you regarding this event trigger updaters. Okay. Okay. So why it is important for an OSPF, and still there is no replacement of OSPF, by the way. Okay. OSPF is still the king in this routing world. Okay. The protocol we are using is OSPF everywhere, everywhere. Okay. So what is the trigger event? Is, let's suppose if something happened here, then and there only it gonna give this message to the entire network. Okay, it gonna broadcast this message. Those kind of LSA, there are certain things. I gonna go that one in details maybe when we will have a practical for that one. Okay, so it gonna broadcast those messages, and that's a very good part. If nothing happened to this network, if no changes occurred here, they will not disturb the network. Okay, they will not disturb the network. It's complex but accurate. Why it is complex? Again, I'm telling you. Uh, when we are saying a event, this link state, so link state, maybe you guys can have a question, you guys can argue, sir. Yes, sir, even what do you think that we have a thousands and millions of routers, and all those routers are not having any problem? Of course, maybe every minute or every hour, some part of the world or some part of the country, some router is having a problem. So, sir, if there is a problem, and if it gonna create a this event triggered update, it gonna create a problem as a like a network overhead, as you were saying that one in distance vector, there is a periodic update, and it is not a good thing because it is creating a network overhead. So here is also is happening. So what is the benefit then? Benefit is there. Cisco recommendation is that in one network you keep max to max 50 uh, router in OSPF. Okay, but that is not a mandatory thing. You can put 500 or 1000 routers in one area kind of thing. So the word came now is area. Okay, what is that? Imagine again. I don't have a the writing pad. That's a big problem for me. So I'm trying to manage here. Okay, so imagine this is one part of the world and it is having one network. Let's suppose one company is having a branch office here, and here is OSPF. Here is also OSPF. Here is also OSPF. Here is also OSPF. If something happens here, it's a trigger update, right? So it gonna contact with everyone. Okay, again, that's not a good thing. So what Cisco recommends is you create a boundary, you create a area. So area is, let's suppose this is area 0, area 1, area 2, area 3. And whatever happen in this particular network, it will not send this message to this area. It will be under this area only. and only the router which gonna connect that is called ABR, area border router. Okay, this area border router gonna connect or gonna give the information from here to here. Okay, so this is how they reduce all those kind of a broadcast packet. It will not go beyond this one. That's the ultimate protocol we have, this OSPF. Examination point of view, very, very important. Interview point of view, definitely they're gonna ask you some questions. This what is this OSPF? Why we are using OSPF? What are the advantage? What are all the packets in the packet size of OSPF? What are all the steps in OSPF? How these guys are talking? Okay, so when we will have a practical, I gonna talk that day also about this one. Okay, so that was a basic difference. Okay, distance vector and the links. Of course, it's the complex thing. Why complex thing? Imagine no, now we have to divide the area in distance vector. We don't have any problem because let's suppose hey, this one is router, this one is router, all routers are connected. Whatever it is, I have a information I gonna share only with my neighbor. My neighbor is only the directly connected one. My neighbor won't be here, this one guy. Okay, so distance vector is pretty easy to configure, but this link state, it is little bit difficult. Okay, but it's ultimate. The kind of a benefit we are getting it from the OSPF is the ultimate. Okay, rapid convergence. Why? Because if something happen here right now, it won't wait for us a time. Okay, now after 1 minute I have to send this message, or after 30 seconds I have to send this message. No, then and there, if something happen here, then and there they're gonna send this message. Okay, and it's a loop free design. Very good design. This design. Okay, and right. And then we have a hybrid protocol that's a based off both worlds. Okay, what does it mean? Based off both worlds means like it is having a distance vector as well as the link state combination, and this EIGRP is basically your Cisco protocol. On Cisco devices, it was a proprietary before, but now they have opened it for everyone now. And there are certain limitation with the RIP protocol. RIP is basically your distance vector protocol. That limitations are only 15 hop is possible, right? So after 15 hop, they won't understand the data. It will go in the loop. Okay. So 15 hop, it is working very good. Okay. And then in RIP, we have basically examination point of view. Maybe they're gonna ask you the question. The RIP, what are the types of RIP? So you're gonna say that RIP is having a two types or two version, RIP and RIP version 2. Okay, so RIP 1, or let's say normal RIP, is having a problem that it only works with the classful IP address. Yesterday we covered the subnetting part, right? So subnetting, what we did, we have a classful address, means like a /8 /16 and /24. That's a classful address. Okay, the class A, B, C, it belongs to some classes. But if it doesn't belong to some class, if you remember last class, what we did, we take 4 bit from the host part, and by default it became the 240 /28, or 255.255.240, if you remember the previous day class. Okay, so that if it is a classless IP address, RIP version 1 was not supported. Okay, RIP version 1 was only working with classful. So examination point of view, again, very important. Okay, interview point of view also, they're gonna trick you whether you have a basic understanding of RIP or not. Okay, even though we are not working, not implementing RIP in the our production environment, but they will ask you the question just to check your knowledge. Okay, so these things you have to keep in mind, that when we are, they will say, okay, we have a subnetted IP address. Whether you're gonna use the version 1, definitely you're gonna say no, it won't. It is not possible. Okay, and I don't know how much we're gonna cover it in next 7 days are left. So if we have a time, I'm gonna show you the whether uh, this with subnetted IP also we're gonna use in the routing thing. Okay, so let me go quickly. Uh, I'm gonna open a question session for you guys because few of your friends asked, and then I'm gonna go for the practical lab session. Okay, so yeah, Pooja, if you have question, you can ask now. Or anyone else, if you guys have a question, you can ask. Where she go? Pooja,
Yes, sir.
yeah, you have any question?
So my question was that whatever I was listening, I'm getting what you said, and I'm actually my English is little bit weak, and I'm getting only English some word.
Okay, okay. Let me see. Okay, Dari and Dana is there. Okay, Dari and Dana, I gonna talk with this another listener in little bit Nepali. Okay, and
Yeah,
maybe
please, I want only.
and you guys can understand Hindi also. So maybe
Not,
this.
I'm not saying totally you stop to this English. Just some word in
Okay, okay,
some
okay,
time.
okay, 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 okay. So के छ अहिले जति हामी कुरा गऱ्यौँ नि यो मेरो नेपाली पनि त्यति नै धेरै
हजुर हजुर
राम्रो होइन
भन्नु
है
न मैले
सो
बुझिरहेको छु
यु
भन्नुहोस्।
यु हेभ टु बियर विथ मी सो जति हाम्रो राउटिङ प्रोटोकल छ नि राउटिङ प्रोटोकल दुई खालको छ है डिस्टेन्स वेक्टर एन्ड लिङ्क स्टेट डिस्टेन्स वेक्टरमा के छ कि लिमिटेसन के छ कि हामी 15वटा राउटर मात्रै हामी कनेक्ट गर्न सक्छौँ अगर हाम्रो नेटवर्क धेरै ठुलो छ त वी कान्ट कनेक्टेड ओके वी हेभ अ लिमिटेसन अनदर लिमिटेसन इज कि हरेक 30 सेकेन्डमा उहाँले छ म्यासेज गर्छ आफ्नो छिमेकीसँग म्यासेज गर्छ आफ्नो छिमेकी मतलब कि मेरो बगलको राउटर जुन छ त्यसकोसँग म कुरा गर्छु किन कुरा गर्छु कि बिना कुरा गरे त हामी अगाडि त थाहै चल्दैन कि भाइ यो
चल
टोल मोहल्ला गलीमा के भइरहेछ एकअर्कासँग कुरा गर्नुपर्छ अरे दोज काइन्ड अफ थिङ होइन सो द्याट वाज अगेन अ लिमिटेसन अब यो हमेसा एक और हरेक 30 सेकेन्डमा कुरा गरिरहेछ अगर हरेक 30 सेकेन्डमा कुरा गरिरहेछ नट अ भेरी गुड सिनारियो किन गुड सिनारियो छैन अब बेमतलबको जवाब दिइरहेछ अहिले पनि नेपालमा के कमेडी चलिरहेको थियो कि आर्मी के पुलिस डिपार्टमेन्ट के भनिरहेछ रातको फ्लस नगर्ने आवाज आइरहेछ त्यस्तै त्यस्तै कमेडी गरिरहेछ होइन नेटवर्कको जबरजस्तीको नेटवर्क ओभरहेड बनिरहेछ सानैतिर पनि कुरा छ हरेक 30 सेकेन्डमा गरिरहेछ सो फर
Yes.
द्याट अल नट अ गुड रिजल्ट वी हेभ के अरे कि राम्रो प्रोटोकल राम्रो एल्गोरिदम आयो जसमा डाइकेस्ट्रा एल्गोरिदम तपाईँ सब पढ्नु भएको होला होइन सर्टेस्ट पाथ फर्स्ट होइन एसपिए भन्छ नि ओपन सर्टेड पाथ जुन उसको पछाडिको एल्गोरिदम छ त्यही डाइकेस्ट्रा एल्गोरिदम तपाईँ सब युनिभर्सिटी लेभलमा पनि पढ्नु भएको होला होइन त त्यो
Yes.
एल्गोरिदम लगाएर के भयो कि भाइ न- हामी मात्रै छिमेकीसँग कुरा गर्दैन हामी पुरा
Yes.
टोल मोहल्लाको जानकारी राख्छौँ प्लस जुन बेलामा हामीलाई समस्या हुन्छ त्यही बेलामा मात्रै हामी आफ्नो कुनै टोल मोहल्लाको मान्छेले परेशान गर्छौँ या कुनै उहाँले सम्पर्क गर्छौँ होइन त दोज काइन्ड अफ थिङ्स वी आर गेटिङ इन लिङ्क स्टेट ओके लिङ्क स्टेटमा अझै धेरैवटा बेनिफिट के छ कि लेट्स सपोज अगर मलाई मतलब कि वार्ड नम्बर 1 छ वार्ड नम्बर 2 छ वार्ड नम्बर 3 छ होइन त वार्ड नम्बर 1 को मान्छेले वार्ड नम्बर 2 को मान्छेसँग छ नि कुरा गर्न जरुरतै परेन उहाँले मतलब कि उहाँले अगर केही समस्या भयो त उहाँले आफ्नो वाडा सदस्य आफ्नो वाडा अध्यक्षसँग मात्रै कुरा गर्छ त्यो वाडा अध्यक्ष के गर्छ कि अर्कोसँग वाडा अध्यक्षसँग कुरा गर्छ या फेरि मेयरसँग कुरा गर्छ त्यस्तै खालको यो सिनेरियो बुझ्नु होइन त त्यो एरिया बोर्डर राउटर भन्छौँ हामी होइन त्यो एरिया बोर्डर राउटर एरिया एरिया डिसाइड गरेर हामी त्यस्तै काम गर्छौँ होइन त्यस्तै कुरा भयौँ होइन यो दुइटाको इक्जाम्पल प्लस हामी अरू के कुरा गऱ्यौँ कि रिपको जो छ दुईटा भर्जन हुन्छ रिप 1 एन्ड रिप 2 होइन कहिले कहिले रिप 1 भन्दैन नर्मल रिप भन्छौँ अरू रिप भर्जन 2 को लागि रिप भर्जन 2 भन्छौँ हामी होइन त्यो रिप भर्जन 2 मा के छ फेसिलिटी जुन क्लासलेस आइपी छ नि त्यो पनि काम गर्छ होइन क्लासलेस भनेको सबनेटेड आइपी पनि काम गर्छ है क्लास फुल एड्रेस के भने जुनकोसँग कि एक्ज्याक्टली /8 या /16 या /24 यानि क्लास एबिसी को छ त्यो मात्रै काम गर्छ कहाँ अरे रिप भर्जन 1 मा यो छ
Yes.
लिमिटेसन थियो त्यति नै हो अझै केही छ कोही नबुझ्ने खालको चिज त भन्नु है
सर मैले बुझ्न धेरै कुरा बुझिसकेँ किनकि मैले यो पहिले पनि पढेको थिएँ। अब म तपाईँले पढाएको अनुसार म अलिक आफ्नो तरिकाले नोट बनाउँदैछु होइन। अरू
ठिक छ
केही
ठिक
काहीँ क्युरी आयो भने केही पनि क्वेसन आयो भने म तपाईँलाई मेसेज गर्छु भन्छु
ठिक छ
अनि
ओके
अब
ओके
अरूसँग
ओके ल
गर्नु।
ल ल अब दोबारा म्युट गर्नु तपाईँ एनीवन एल्स ह्याभिङ एनी क्वेसन नो है देन आई गो फर lab part with for this one okay let me again share with my screen But why it is taking time to open? What happened? What the hell? Hmm. Okay. So today, I gonna make a very small scenario. Okay. What is small scenario I gonna make? I gonna take at least two, three routers. I gonna take it. Okay, so I will take the three routers. Basically, these are the routers. Okay. And what else? I'm gonna take switches also. One switch I will take. Okay. Then I gonna connect first these switches to the router. This router to this router. And guys, whatever I'm doing it here now, and I'm demonstrating to you guys have to practice it. Practice. I mean, otherwise it won't be very, helpful for you guys if you are not practicing. It will always look very simple, simpler, when you are looking at it, either in YouTube or whatever. Mandeep Kharel. Okay, so. I'll tell you what I'm doing. Okay, this is, let's suppose, one of the branch office of any company, or maybe let's say it's a multinational company. Okay, so this multinational company, this is the US branch. Okay, US head office, you can say. This is India, this is Pakistan or Bangladesh or Nepal, whatever you can imagine. Okay, and of course, it won't be connected. If it is a branch office, it won't be directly connected like this. Again, no one has that much money that they will lay down their private cable from here to here. Okay, for of course that there, what will happen here? Some ISP will be here, another ISP will be here, and these ISPs are already having a cable connected with them, and these two branch office, they're gonna take the line from the ISP. Okay, those will be the like real time scenario. Okay, but for our lab scenario, we can't help you out. Okay, so here what we're gonna do, we're gonna create a different network. Let's suppose this will be our 1.0 network. Okay, 1.0 means 192.1 we will take. Okay, 192.168.1.10. Okay, and as we talk about the router, so definitely we need a gateway to reach to our router. Okay, so the by default gateway I put it 1.1 and the IP I put 1.10. Okay, and with this one PC, first we're gonna configure the PC 192.168.2.10, and the gateway is 192.168.2.1. Okay, and with this PC I gonna take 192.168.3.10, and then 192.168.3.1 is our will be our default gateway for that network. Okay. So till now what we have configured is a IP address or identification of complete identification of PCs has been provided. Okay. Now, do we need to configure this switch? Of course, in a real world for sure, but in our lab environment, till right now we don't need to configure it. Yesterday we already covered this VLAN part. So you imagine that there is a VLAN here. By default, you already know, or we already discussed, if we have not configured any VLAN, there is a native VLAN, all parts of the VLAN one. So there is no problem, nothing to configure at. Till in our lab session, we don't need to configure. But for sure, if it is a real time, definitely there will be like a very different department attached to each and every branch office. So accordingly, we have to configure the VLAN part also. Okay, but for our lab scenario, we are fine here. Okay, now whatever the default gateway we put it here. Okay, or here, the all the branch offices. Okay, what will be the default gateway? What is default gateway, by the way? Default gateway is, let's suppose we have another PC. Imagine, let's suppose I take one PC here, okay, and I gonna connect it from this switch to this PC, okay. So these two switches, these two PCs are from the same, you can say, the network. So when they want to talk to each other, what this PC is doing, they have something called AND operation. You guys have understand in digital logic class, okay? So they do the AND operation with the subnet mask and then the IP address. Because if you remember, few of guys maybe they have missed our network layer classes and the other model, OSI and the TCP/IP model classes. In that one, we were discussing it. For each and every communication to be happened or to be connect finish in a successful way or a unsuccessful way also, it need to go through all the layers. Okay, so all the layer will have their own PDU, and with that PDU they will have a trailer and header. Okay, so here in network layer trailer and header, there is an IP address, source IP address and the destination IP address. Okay, and their mask also. So they're gonna do all sorts of what and operation, and they're gonna find it whether this is from our my network or yes or no. Okay, if it is in their network, they don't need the default gateway. Whatever the default gateway we configured it here, no, this 2.1, they will not search this 2.1 IP address, whoever it is, they will not search it. But this guy, if they wanted to ping this particular guy, okay, maybe here is they having a here, uh, let's suppose they have a web server here and the clients are here. So this client, if they are trying to access the web server which is in the head office at US, they definitely need to go through the router, the default gateway. Okay, so this default gateway, what will be the IP address where we gonna configure the default gateway? The port which this network is connected to. Okay, so you have to always be confident about this one. So let's suppose this is the router, right? Okay, so this router is having a two port. One port is connected to this switches, and another port connected to the another router. So what will be the default gateway for this network? Whatever the port, this network is directly connected. So this network is directly connected with the port GI 0 by 1. Okay, so you have to configure the GI 0 by 1. Okay, so go here, enable config mode, and then you're gonna say int GI 0 by 1. Okay, so we are in the interface now, GI 0 by 1. Now what the IP address we have to configure here? The default gateway. What the default gateway we put it here? 2.1. Okay, so we're gonna say IP address 192.168.2.1, subnet mask 255.255.255.0. Okay, and then no sat. Why no sat? Because by default, all the ports are in the shutdown states. Okay, no sat. If we're gonna put the no sat, you see there the status is changed to up, and you can see here also previously it was a red symbol here or red notification. It converted to the green. Okay, that's it. Then now what we did, we only configured till now the IP address. We didn't touch anything related to the routing protocol. Okay, so first let us finish the gateway part for each and everyone. Then I gonna go ahead. Okay. So here also we go config modes. Okay. then int again here gi 0 by 1 IP address that was 3.1. So 255.255.255.0 and no such. Okay. Similarly, here also I'm teaching it. Yes, still I'm teaching. Sorry, where my baby was asking me something. Anyway, so IP interface here also GI 0 by 0 is here. Okay. And IP address for this one is 192.168.1.1, 255.255.255.0. Okay, and then the no sub. Okay, so till now, what we did, we have just configured our branch router, and towards the our LAN area we have configured it. But what still we didn't configure it, how we are going from our branch office to the head office. Okay, so in the real world, definitely there will be an ISP here, and the ISP will take your packet or take your data in the from in their network, and they're gonna give you the best route possible with them, and they will give us a one public IP address, and we're gonna configure that public IP address at our this switch. Okay, but in our this lab environment, what we're gonna do, we this is our 1.0 network, this is our 2.0 network, this is our 3.0 network. We're gonna make this one 4 and 5.0, 4.0 and 5.0 network. Okay, what does it mean? Okay, some of you guys are saying, please talk in Nepali. Okay, better. Instead of Nepali, I'm gonna talk a little bit Hindi. Okay, because few of our listener they can understand Hindi also from the English. Okay. Uh, okay, okay. Uh, मैं क्या बोल रहा था कि अभी तक जो हम लोग कॉन्फ़िगर किए हैं, वो हम लोग का जो ब्रांच ऑफिस का जो अपना नेटवर्क है, उस नेटवर्क को हम लोग कॉन्फ़िगर किए हैं। ओके, और जो अपना नेटवर्क जो है उस नेटवर्क को हमें जो डिफॉल्ट गेटवे जरूरत है, वो डिफॉल्ट गेटवे भी हम लोग अपने राउटर पे कॉन्फ़िगर कर चुके हैं। बट व्हाट वी नीड इज हाउ आवर हमारा ब्रांच ऑफिस कैसे हमारे हेड ऑफिस से कनेक्ट करेगा। सो इन रियल वर्ल्ड वी हैव आईएसपी, इंटरनेट सर्विस प्रोवाइडर वी हैव। सो वो हम लोग का पैकेट लेके जाएगा अपने नेटवर्क के थ्रू। बट इन आवर लैब सिनेरियो व्हाट वी गोना डू कि इस नेटवर्क को हम लोग 4.0, लेट्स सपोज हमारा ये नेटवर्क जो है 1.0 था, ये 2.0 कॉन्फ़िगर किए हैं, ये 3.0, इस नेटवर्क को हम लोग 4.0 और इस वाले को हम लोग 5.0 में कन्वर्ट करेंगे। ओके, सो and the one thing is should be very clear, when you are configuring the IP address of this one, we are saying the 4.0. Okay, so 4.0 means these two IP supposed to ping each other. Okay, so don't be confused here. Okay, I gonna give here some other different IP, and this one will be very different network IP. So then our network is not possible. Okay, so what we have to do, interface again GI 0 by 1. Okay, and then we're gonna configure here IP address 192.168.4.0. So 4.0 means any IP from the 4.0. It was, let's suppose we are taking 4.10, or not, sorry, 1, take 4.1, 4.1, 255.255.255.0. Okay, and then no shut. Okay, every time why no shut? Because by default these particular ports are in the shutdown state. Okay, now we have to configure here GI 0 by 0 this side. Okay, so interface GI 0 by 0. Okay, then IP address 192.168.4.2, 255.255.255.0. You see here, I give 4.1 here and 4.2 here. I could have given anything 4.200 here, 4.199 or 4.100. As long as these two IP can ping each other, we are fine. Okay, and then here no start. If you will do the no start now, you can now see here. Now the link is green between this one. Okay, this both link is supposed to be configured to be green. Okay, similarly we have to configure this one also, this switch. Okay, so in this router we have GI 0/2 port. Okay, GI, sorry, interface GI 0/2. Okay, IP address 192.168. We will take the 5 dot network. Okay, 5.1 255.255.255.0. Okay, and then the no start. And similarly, we have to configure this router, and the port is connected is GI 0/0. So interface GI 0/0, and then IP address is 192.168.5.2. Okay, and then 255.255.255.0. That's it. No start. Now, what we have covered till now, that we have given the IP address and that identification to all our in devices at the branch office and the head office, and we have configured the our gateway. We have now configured the IP address between this branch office and the head office. Does that mean that this particular all this network gonna able to reach to each other? Anyone can give me this answer? I just wanted to know whether how much you guys have understand this network or the previous knowledge. Whether this switch, this particular PC will be able to ping this one? No.
Of course, sir.
What? Of course, it will ping.
Yes,
So
sir.
okay, so let's see. If you are saying, let's see whether it is able to ping. Okay, maybe one packet failed. So you can see, sir, the very first packet is for ARP. That's why it is failed. It will fail all the time. All the time it will fail.
So I'm getting it.
Reason behind that one is because we have not configured the routing. Okay.
Uh,
Okay. Now again, with this scenario, within this same network, I'm again asking you the question. Let's suppose this router, right? This is here. So if I could have, okay, leave it, leave it. So this particular PC gonna ping to this one? No. Okay. The
no.
router which is directly connected with the port, they will have the information. For an example, if you remember just now we configured 4.1 here and 4.2 here. Okay.
Yes, sir.
So this particular PC will be able to ping that 4.1 and 4.2. Yes or no? It was ping
Yes,
192.168.4.1. This PC will be able to ping, yes or no?
yes.
Because
Because
it
they're
is,
same ground.
yeah,
Yeah, yes.
it is connected with the same router, okay? And this they will be able to ping 4.2
Yes, yes.
also. But there is having a problem. Okay, no problem. We'll fix it. So anyway, the routing part still we didn't configure it. Okay, so today we will configure the distance vector read protocol. Okay, so how we gonna configure it? We have to think when we are saying distance vector, this particular router gonna talk with their neighbor only. So what, who is the neighbor for this router? This one only, not this one. Neighbor is directly connected, router is neighbor. So these two routers are not directly connected, but this router is connected to this network. Okay, and this router is connected to this network. Okay, so we have to give the information about the directly connected network inside our routing protocol information. Okay, so how we going to configure that one? You just exit it, go to the global configuration mode. So we are in the global configuration mode now, and we are in here. router 0. So router 0, this side is 1.0, this side is 4.0 network. So you have to give this network address to the protocol. You have to give this information inside the protocol configuration. So the very first command we're gonna use is router rep version 2. So this is how we enable the routing protocol, that is RIP, that is distance vector protocol version 2 on this particular router. Okay. Now we are saying there is a network which is directly connected with us, and that network is 192.168.1.0. See, now we are not saying 1.1, 1.10, 1.2 or something like that. Network part. You remember the subnetting part we are saying, or the maximum host we are saying, why we have only 254 hosts possible in our class C. All the way there are 8 bits. So 8-bit combination is 2 to the power 8. That's supposed to be 256. But we are saying maximum 254 host is possible. The reason behind that one is the very zero part, all zero part is your network part, and all one part is your broadcast path. So this is how the network looks like. So network 1.0. This is our network. You have to provide the network address. Now again, this network is another side, it is connected with 4.0. That's it. Okay. And here also you have to do the same thing. Router rep version 2, and then the network 192.168.4.0. This router is again connected with the 4.0, 3.0, and 5.0. So 4.0, 3.0, and then 5.0. So this router is connected with the 3 network, and let's go with this router. And here router rep version 2, network 192.168.5.0, because this particular network is 5.0 and this one is our 2.0, 5.0, and then the 2.0. Now we have configured all the router, and we have given the instruction to the router that they have to use the distance vector routing protocol, that is RIP, and we have given them that these are the network they have to consider when they're gonna talk with their neighbors. Okay. Now, can we check here? So IP route. Okay. So this is how we're gonna see whether we have a routing information or the path, we have any path to reach to the destination where we are not directly connected. Okay. And if it is a router RIP, that is a RIP protocol, it will display with the R. You can see here there are R. Okay. So you can see we are here on the router 1. Okay, where we are here, router 1. Router 1 is directly connected with 2.0 and 5.0. This router doesn't have any information this about 3.0 and 4.0 and 1.0. So you can see here 3.0, to reach to that 3.0 they have to go through 5.1. And if you remember, we have configured this particular port. This is 5.2 and this is 5.1. So definitely when this router want to go or reach this particular 3.0 network, it will go via this one. Even if they wanted to go this particular network, that is a 4.0 or 1.0, definitely they have only one option, that is 5.1. So you can see here the 4.0, 5.0, and all the way they have what they have to use is 5.1. Okay. So now previously, if you can see, it was having a failed. So if all the router is having a routing database with them, so they can ping. If, see, it is successful now. Why? Because all the routers is having a database with them. How we gonna check the database? How we gonna check the whether it has been configured properly or not? You can see so IP root, and it will give you the information about the network which is not directly connected with these routers. Okay, and what is the the next hop from where this packet from where our packet will go. So imagine this is our 1.0. So this router doesn't have information about 2.0. This is 3.0, and this is 5.0. 4.0 they have information because the router is having a directly connected information. So here 2.0, 3.0, okay, these 2.0 and 3.0 they will go through the 4.2, and this is where the 4.2 we configured. Okay, so that's it, guys, and you can check here from here to here also. The very first packet drops because of this ARP. I didn't cover the ARP. I will cover the ARP later. So you can see that second packet is successful. Okay, so and here also, if you remember, okay, leave it. So that's it, guys. That's it from my side. If you guys have any question query regarding theory session as well as the lab session, you can ask. Doesn't have any question? Okay, then that's it. Then that. See you guys tomorrow then.